June 3, 1944. 0617 hours. Northern outskirts of Cannes, France. Cold morning mist drifted between shattered homes and broken walls. The front line shifted every hour. German armor probed the corridor that led toward the city center. The constant threat of a Panzer push forced Allied infantry to fortify every ruined street. Artillery had collapsed most of the timber homes into heaps of jagged beams and cracked brick. Patrols moved through this wreckage with caution. Snipers watched every gap. Tank crews listened for the echo of a bazooka round. The battle for Cannes punished anyone who hesitated. Sergeant Thomas O'Connell crouched inside the skeleton of a bombed Porch. Only the support posts and a fractured beam remained. He watched his platoon struggle to set up another standard anti-tank position on the corner of a destroyed bakery. The crew dragged sandbags, set a predictable angle, and repeated the same steps they had used since Sicily. O'Connell had seen those setups fail again and again in this dense environment. German tank commanders learned the rhythm of Allied doctrine. They mapped lines of fire. They expected each emplacement to appear at the same height and angle. Every time an Allied crew followed the manual without variation, a Panzer adjusted. The result was always the same. The tank fired first. The crew died before they fired a second shot. O'Connell, 28 years old, carried a skill set suited to this battlefield. Before the war he worked as a master carpenter. He built timber frame roofs in industrial neighborhoods. He repaired porch beams, warehouse rafters, and bridge supports. He learned how weight traveled through wood. He judged structural stress by sound and touch. He could understand a fractured beam with one glance. That civilian experience shaped how he viewed ruined houses. Other soldiers saw wreckage. O'Connell saw reinforced angles, predictable load points, and stable firing platforms hidden under debris. His eye searched for natural lines that no enemy would expect. He noticed a porch beam with a jagged break near its center. A collapsed floor above it pressed downward, locking it in place. This created a low, narrow wedge between the beam and a cracked stone wall. Dust coated the gap. The angle was tight but stable. O'Connell placed his hand on it and felt zero vibration. This was a perfect improvised firing channel. It sat well below the normal line of sight for tanks. An armored vehicle scanning for anti-tank rifles would never look this low. The beam masked muzzle flash. Smoke vented through a loose seam. The tank would think the shot came from a different street. He tested the angle. Through the small space he saw 50 meters of open road that German armor used as a staging lane. No standard emplacement could aim this low or fire from this odd position. The gap forced the rifle to rest at a unique angle that matched the beam's contour. The wood acted as a stabilizer. The beam carried recoil into the ground instead of into the shooter's shoulder. This gave O'Connell a clean shot line that no manual described. He spent the next hour carving the opening with his field knife. He trimmed splinters, widened the base, and reinforced a weak joint with scavenged nails. Each cut followed the natural grain of the beam. He judged the pressure by sound. If the wood creaked, he stopped. If the joint held quiet under weight, he expanded it. His mind worked with the precision he used in pre-war construction. The small structure became a functional, concealed firing gap. When he finished, the beam looked untouched from the outside. Captain Davies arrived during inspection rounds. Davies valued discipline and expected full adherence to doctrine. He studied the beam, frowned, and ordered the structure dismantled. He considered it unsafe and non-standard. He believed any soldier inside it risked being crushed if the beam collapsed. Davies preferred predictable positions that headquarters approved years earlier. His voice carried authority. O'Connell nodded out of respect, but inside he refused to surrender the idea. He had seen too many men die from predictable setups. He cleaned the edges, hid the reinforcement, and preserved the firing gap. He trusted his judgment more than the manual. By afternoon, the battalion command post received warnings of a German armored group shifting south toward their sector. Intercepted reports mentioned a Panzer IV moving with infantry support. These armored pushes often killed dozens of men before the Allies could organize a response. The streets around O'Connell's sector had poor visibility, narrow lanes, and collapsed corners that blocked standard firing angles. The only reliable way to stop a tank was to fire from an unexpected place at an unexpected height. Every crew that tried conventional angles failed in these streets. 2 nights earlier, a bazooka team positioned behind a broken fountain fired at a Panzer approaching from the east. Their shot struck armor at a bad angle. The tank pivoted, spotted their location, and killed them before they reloaded. The next day, a second team tried a sandbag setup in a warehouse corner. Their position fell under machine gun fire before they could aim. Casualties mounted. Command sought better cover, but the urban terrain offered little. Doctrines shaped for open fields did not translate to fractured streets. O'Connell stayed near his porch beam gap and studied the ground again. The angle matched the road. The elevation matched the height of the Panzer's lower hull. If the tank advanced along its usual path, the shot would strike near the crew compartment seam. This weakness was known but hard to reach. Only a shot fired from a low, stable platform could hit it accurately. Regular positions fired too high. He prepared his anti-tank rifle. He wiped dust from the barrel. He checked the bolt. He placed his shoulder lightly against the beam to test vibration. It remained steady. He lowered his breathing. The morning fog thinned, but enough haze remained to mask smoke. The men around him moved sandbags to higher ground, unaware that the lowest and tightest gap held the best defensive potential. German artillery fired sporadically to feel out Allied movement. Shells landed 3 streets away. The blast shook loose dust from the ceiling above him. The beam did not shift. That confirmed the structure could withstand tank vibration passing nearby. O'Connell made small mental notes. Stable beam. Low signature. Clear lane. 0 silhouette exposure. By 1600 hours, the sound of tracks echoed faintly from the east. Scouts confirmed a Panzer IV with infantry screens. Every man in the platoon tensed. Standard procedure required each anti-tank unit to follow preset positions. O'Connell's setup remained unofficial. He sat alone inside the collapsed porch while the others spread out across predictable corners. Davies walked past him with a cold stare. He still viewed the porch beam idea as unnecessary risk. He tasked O'Connell with basic rifle support, unaware of the tactical advantage hidden under the broken wood. O'Connell remained silent. He understood the value of the structure. He waited for the tank to appear. The ground shake grew stronger. Metal clattered. Boots struck pavement. The Panzer moved slowly, using infantry as feelers. The crew expected rockets from second-floor windows. They expected sandbag nests behind corners. They did not expect a shot from a beam gap near ground level. They banned his porch beam firing gap until it dropped a Panzer crew. The Panzer's turret rotated left, then right. The commander scanned rooftops for Allied positions. Infantry squads moved tight along the walls, rifles raised. They advanced with the confidence of men who had learned the rhythm of this battlefield. They believed they understood Allied defensive habits. Every engagement reinforced that belief. O'Connell recognized this pattern. Predictability shaped the decisions of both armies. His improvised gap targeted that weakness. The tank pushed debris aside as it entered the narrow road. Its tracks crushed broken stone and splintered boards. O'Connell steadied his rifle. He waited for the tank to pass a jagged chimney stub that marked his range estimate. When the Panzer reached that point, the angle of his firing gap would align perfectly with the lower crew compartment seam. He tightened his grip and remained still. Infantry passed within 20 meters of his position. Dust-covered boots moved quickly. They saw a collapsed porch with no movement, no barrel, no open line of sight. The firing gap sat too low for a human eye to detect. O'Connell waited. His heartbeat slowed. He blocked out the sound of his own breath. He focused on the tank's left track guard, watching how it tilted while rolling over uneven ground. That tilt would determine the exact alignment of his shot. Captain Davies signaled other teams to hold fire. He intended a coordinated volley. O'Connell ignored it. If every crew waited for the order, the tank would detect the buildup. The Panzer commander would pivot the turret, fire a blind shot, and force the infantry to retreat. Standard tactics relied on perfect coordination. Urban terrain rewarded individual precision. The tank moved closer. O'Connell lowered the rifle a fraction of an inch. The beam held its weight without movement. The muzzle sat deep enough inside the gap that even observers standing directly outside would not see it. He calculated wind. None. Distance. 59 meters. Angle. 8 degrees downward. Expected armor response. 2-second delay before turret correction. The Panzer's hull aligned with the chimney stub. O'Connell inhaled once. He aimed for the weak point just above the hull seam near the driver's side. He pressed the trigger. The round left the barrel in a controlled burst. The recoil drove into the beam, not his shoulder. The porch transferred the energy into the ground. His silhouette remained invisible. Smoke vented through a loose board, masking the origin of the shot. The impact struck the Panzer exactly where he predicted. The round penetrated the seam, shattering internal components. The driver slumped instantly. The tank lurched. The commander shouted orders. Confusion rippled through the infantry. They did not know where the shot came from. Their eyes went to rooftops and windows. None looked down at the broken porch. The tank halted. Its turret swung wildly. O'Connell chambered another round. He timed the turret's movement and fired again. The second shot punched through the lower front plate. Flames flickered inside the compartment. The crew panicked. One man opened the hatch. Machine gun fire from Allied positions pinned him. He fell back inside. A third shot from O'Connell hit the gunner's position. Metal fragments burst outward. Smoke thickened. The Panzer stopped moving. The engine stalled. Davies stared in disbelief. The tank fell to a single improvised position that he had banned hours earlier. The platoon pushed forward with renewed aggression. Infantry seized cover and fired at the disoriented German soldiers. Without tank support, the enemy infantry retreated. The street shifted under Allied control. Davies approached O'Connell's position. He scanned the porch beam, studied the angle, and saw the precision of the construction. His expression changed. He recognized that the shot line matched no known manual. This low trajectory exploited a blind angle that German crews never considered. O'Connell revealed how structural debris could transform into a tactical advantage. Davies understood what that meant for the larger fight. O'Connell explained how he formed the gap. He described the reinforced beam, the pressure distribution, and the angle calculation. He spoke with the same tone he used when explaining roof weight distribution before the war. Davies listened without interruption. His rigid adherence to doctrine weakened in the face of undeniable results. He issued new orders. Every squad would scout buildings for low structural firing gaps. Carpenters, engineers, and laborers would reinforce beams and create concealed shot lines at irregular angles. The tactic spread through the platoon within hours. By nightfall, 2 more positions adopted O'Connell's design. Scouts marked stable beams with chalk. Soldiers cut narrow channels inside collapsed porches. Reinforced angles replaced standard sandbag nests. German armor struggled to respond. They expected high-angle shots. They expected second-floor ambushes. They never expected fire from ground-level structural beams. Reports spread to company headquarters. Officers demanded detailed sketches. O'Connell provided rough diagrams on scrap paper. These drawings showed weight paths, reinforcement points, and angles that fit typical street geometry. For the first time in weeks, Allied positions held against armor without catastrophic casualties. Each firing gap required only 1 soldier. Visibility stayed nearly zero. The muzzle flash disappeared inside the wood. Tanks wasted rounds firing at false angles. German crews adapted slowly. They increased shelling of low positions. They fired at rubble piles and collapsed porches. That reaction confirmed the effectiveness of the tactic. When an enemy dedicates fire to unknown threats, the defense gains leverage. O'Connell walked through each street at dawn and studied how shells hit the debris. He found which beams survived and which ones failed. He refined the design further and taught others how to detect stable structures. His platoon followed his guidance. They learned how to test beam strength by tapping the wood lightly and listening for vibration. They learned how to carve gaps without weakening the joint. They learned how to align angles using street markers. The tactic became a routine procedure that cost nothing, required no extra equipment, and produced outsized results in urban combat. The next major engagement came 3 days later. A heavier group of German armor pushed into the district. This time, 6 improvised firing gaps stood ready. Each gap held a rifleman who understood the angle and the shot line. When the first tank entered the sector, it took fire from 4 directions at angles too low and too precise to trace. The crew panicked and reversed. Infantry broke under fire from multiple streets. The armored thrust collapsed. O'Connell observed the fight. He noted how each beam transferred recoil. He watched how the tank reacted when hit from different directions. He recorded distances. He improved each design again. He suggested that platoons mark their best beams on a map for future operations. The company commander agreed. As the days passed, the method spread beyond the battalion. Combined units replicated the design in neighboring sectors. Senior officers recognized how a simple structural trick neutralized the predictable nature of urban anti-tank warfare. They filed unofficial reports highlighting the tactic's success. Although no formal doctrine included beam firing gaps, soldiers adopted them instinctively. The local command center received handwritten accounts from multiple platoons. Each report repeated the same pattern. A single reinforced firing gap created consistent kills or forced armored withdrawal. Standard sandbag positions rarely produced similar results in this environment. Officers began to track casualty reduction. They found that squads using beam gaps suffered fewer losses when tanks advanced through narrow roads. Units relying only on standard emplacements saw higher fatalities. These numbers mattered. They shaped decisions more than theory or doctrine. O'Connell reviewed recovered German documents after a patrol captured a courier. The papers included brief notes from tank commanders. One entry described confusing low-angle fire that seemed to come from under-collapsed structures. Another mentioned shots hitting from impossible positions. These observations confirmed that German crews did not understand the new tactic. They assumed a hidden weapon or a new type of emplacement. None realized it used the natural wreckage of buildings. The ruined neighborhoods around favored the approach. Timber beams, fractured porches, and collapsed floors created countless opportunities. O'Connell walked each sector with small groups of soldiers. He pointed out beams that held structural weight. He warned them to avoid unstable joints where debris shifted unpredictably. These short lessons helped soldiers identify firing points without formal training. They learned to see the battlefield through his eyes. His carpentry background became a resource as valuable as any weapon. A week later, a new challenge reached the Allied line. German forces brought a heavier variant of the Panzer IV with upgraded frontal armor. Intelligence feared that the reinforced plates would neutralize low-angle fire. O'Connell studied the new configuration through binoculars during a reconnaissance moment. He noted that the frontal seam remained present, but shifted slightly higher. The firing gap needed adjustment. He measured distance by lining up the beam with street markers and predicted the new angle. He instructed his men to raise their firing gaps by a few centimeters. They carved fresh channels. They reinforced load points. They widened gaps to support rifles without exposing barrels. These changes required precision. One mistake could collapse the beam. The soldiers followed his instructions exactly. When they finished, each gap matched the revised trajectory. The next armored assault came at dusk. The heavier Panzer variant pushed through rubble with loud confidence. Its engine roar dominated the street. Infantry spread out in protective formation. The tank commander scanned windows, doorways, and higher angles. He did not consider the beams near ground level. O'Connell positioned himself inside a newly reinforced gap. The angle felt higher than before. He waited for the tank to roll into range. The road narrowed near a collapsed stable. Once the tank passed that point, its side plate angled downward enough to expose a thin section near the driver's compartment. O'Connell prepared his shot. He watched the tank's movement and timed the recoil cycle. He fired when the hull dipped over debris. The round struck the exposed plate. Sparks burst. Smoke seeped out. The tank slowed but did not stop. O'Connell fired again. The second shot found the seam. Flames erupted from the hatch. Crew voices filled the street. The tank rolled backward and collided with a stone wall. It stopped moving. This engagement proved that the tactic worked even against upgraded armor. The company commander documented the result in detail. He compared the action to traditional anti-tank methods used earlier in the campaign. The difference in effectiveness was sharp. Traditional ambushes required multiple teams and precise timing. Beam gaps required one shooter and one stable angle. The report traveled up the chain of command. German infantry attempted to suppress low positions in later engagements. They fired at rubble and scattered debris with heavy bursts. This response forced Allied soldiers to adapt. They reinforced gaps with 2 beams instead of 1. They added stones behind weak sections. These adjustments preserved structural strength. O'Connell tested each reinforcement with light pressure and sound checks. His men learned the process and replicated it across the district. During a night operation, a German tank attempted to fire directly at a suspected beam gap. The shell struck the porch but failed to collapse the structure. The reinforcement held. O'Connell noted that the impact spread across the load points instead of focusing on the weak center. This confirmed that his reinforcement method worked under heavy fire. Word of the tactic traveled to engineer units. They requested demonstrations. O'Connell showed them how to identify grain patterns in fractured wood. He explained that certain breaks held weight better than others. Engineers took notes. They measured beam thickness and calculated load capacity. They drew simple diagrams that field units could understand quickly. These diagrams circulated through company-level briefings. O'Connell never sought recognition. He focused on improving each gap and training more soldiers. His platoon came to rely on his judgment. His officers began to consult him before setting up defensive lines. He walked each street and selected positions based on structural strength and visibility. This saved lives. By choosing safe, reinforced gaps, he prevented collapses and ensured stable firing angles. One day, a German armored group attempted a coordinated push across the district. Multiple panzers moved simultaneously through parallel lanes. They intended to overwhelm Allied defenses. O'Connell predicted that the tanks would cluster near a particular junction. He arranged firing gaps in advance across that junction. When the tanks arrived, they faced overlapping angles that targeted their vulnerable points. Shots came from positions too small to detect. The tank commanders fired blindly, hitting walls and debris. They failed to identify the shooters. The armored push collapsed in less than 10 minutes. 3 tanks were disabled. Infantry retreated. O'Connell studied the aftermath. He examined damage to the beams. He took note of how the tanks responded. He adjusted positions again. Each adjustment made the tactic more effective. Civilian structures continued to collapse throughout the campaign due to artillery and tank fire. O'Connell taught soldiers how to inspect beams after shelling. If a beam cracked at the wrong angle, the gap became unsafe. He instructed them to abandon it immediately. Safety mattered. A collapsed structure could kill a rifleman before he fired a shot. During one engagement, a nearby building collapsed without warning due to artillery impact. The beam gap inside that building collapsed too. O'Connell assessed the scene and realized that heavier beams survived better. He updated his criteria. He instructed his men to select beams thicker than a rifle stock. This small rule improved safety across the line. Engineers refining the tactic requested more input. O'Connell explained weight distribution and recoil patterns. They tested variations. They found that angling the rifle slightly into the beam increased stability. They found that certain reinforcement points delivered better force transfer. These discoveries came from repeated field use. German forces eventually altered their tactics. They increased the distance between tank and infantry advance. They fired high-explosive rounds into rubble from longer range. This reduced the number of effective firing gaps. O'Connell adapted again. He moved the gaps deeper inside structures. He placed them behind 2 layers of debris. This shielded them from distant fire. German tank crews became cautious. They advanced slowly. They checked low angles more often. Their hesitation cost them momentum. Allied units regained initiative. O'Connell's small innovation influenced battlefield behavior across multiple sectors. The weeks of fighting around can pushed every unit to its limits. Supplies arrived late. Streets changed hands multiple times. Allied officers needed tactics that worked without heavy equipment. O'Connell's firing gaps delivered results with no extra materials. The only requirement was skill and patience. Soldiers across the battalion adopted the method. They taught it to replacements. They included it in nightly briefings. The tactic spread through both formal communication and word of mouth. Officers from neighboring units visited O'Connell's position to observe his work. They saw the narrow gaps carved into porch beams. They watched how he tapped wood to test stability. They saw how he aligned a rifle through the gap with minimal exposure. These officers carried the information back to their sectors. They encouraged their troops to replicate the technique. They reported fewer casualties in later engagements. O'Connell kept moving through each damaged street. He documented which beams held weight after artillery strikes. He recorded which structures created the best shot lines. He built a mental catalog of angles, distances, and structural patterns. This information helped him guide other squads. He rarely stayed in one place. He evaluated positions, advised teams, and reinforced weak points. His platoon trusted his judgment more than any manual. German armored crews faced increasing difficulties. They reported confusing low-angle fire. They struggled to locate the shooters. They wasted ammunition on empty rubble. They advanced cautiously. This caution slowed their attacks. It disrupted their timing. Allied forces used that hesitation to reposition and prepare counterfire. Each delay increased German casualties. A few German units attempted to adapt by firing at ground level whenever they suspected a gap. They damaged structures but rarely hit the actual positions. The gaps sat too deep inside beams to be destroyed without direct hits. Most shells struck surrounding debris or collapsed walls. O'Connell used these effects to refine his reinforcement method again. He added structural wedges behind weak joints. He improved load distribution. His adjustments kept the gaps intact under heavier fire. As confidence grew, some officers suggested using the tactic in coordinated volleys. O'Connell advised against it. He explained that the strength of the method came from unpredictability. If too many shots fired at once, German crews could identify a pattern. They could adjust turret elevation. They could direct artillery to likely beam clusters. O'Connell argued for staggered fire. One shot at a time from unpredictable angles kept tanks guessing. Officers accepted this reasoning. During one operation, intelligence reported that a German armored patrol would attempt to break through the center of the district. The patrol included 2 Panzer IVs and a half-track with infantry support. O'Connell planned positions across the expected route. He selected beams that offered stable recoil support. He placed one gap near a broken staircase and another behind a collapsed bakery. He checked each beam by pushing his weight lightly against it. If the structure creaked, he rejected it. If it remained silent, he approved it. When the German patrol moved in, the tanks advanced cautiously. The infantry scanned high windows. They expected ambush fire from upper floors. The first tank entered the designated kill zone. O'Connell signaled the riflemen through hand gestures. One rifleman fired from a reinforced gap behind the bakery. The shot struck the tank's side plate. The crew panicked. They rotated the turret to face the wrong building. The second rifleman fired from the staircase position. The round hit a lower plate. The engine sputtered. Infantry scattered under Allied fire. The half-track attempted to push through. A third beam gap waited near a collapsed stable. The rifleman there fired at the driver's compartment. The vehicle swerved into debris. The patrol failed. The armored breakthrough collapsed in less than 5 minutes. Allied units secured the street. They captured documents and equipment. The officers noted again that the firing gaps allowed small teams to stop larger forces. As the campaign continued, senior engineers arrived to evaluate the tactic formally. They interviewed O'Connell and examined his firing gaps. They took measurements and tested structural strength with simple tools. They studied how recoil transferred through beams. They confirmed that the method worked because it used the natural angles created by fractured buildings. They drafted quick guides for other units. These guides included sketches of safe beams, unsafe joints, and recommended reinforcement points. O'Connell read these guides with interest. They captured the basics but missed some finer points. He suggested revisions. He emphasized the importance of grain direction. He explained that certain cuts weaken the structure more than others. The engineers accepted his notes. They updated their diagrams. They distributed the improved versions to multiple companies. German commanders grew frustrated. Their armored units reported unpredictable fire from unknown positions. They attempted deeper reconnaissance. Scouts crawled through rubble and inspected beams. They found nothing. The firing gaps stayed hidden. Only soldiers who knew the exact angle could see them. German crews lost confidence in narrow lanes. They avoided certain streets entirely. This gave Allied units more control over movement corridors. O'Connell never forgot the human cost around him. He walked past destroyed buildings with caution. He noticed the remnants of Allied anti-tank teams who died earlier in the campaign. Their sandbag nests stood exposed and predictable. Their positions followed doctrine and cost them their lives. O'Connell respected their sacrifice. He saw his work as a way to save future teams from the same fate. One day, a German armored column launched a sudden push after a barrage of artillery fire. Their goal was to break through a weakened sector and flank the Allied line. The artillery shook the district. Structures collapsed. Dust filled the streets. O'Connell moved quickly to assess damage. Some of his earlier firing gaps collapsed. Others survived with minor cracks. He identified which ones remained safe. He directed soldiers to rotate into those positions. The armored column approached faster than expected. The lead Panzer entered the first lane. A single rifleman fired from a gap that survived the bombardment. The round struck the driver's view slit. The tank jerked. Smoke rose from the hatch. The second tank advanced to cover. Another rifleman fired from deeper inside a wrecked home. His shot hit the turret ring. The turret jammed. Infantry forced a retreat. The sector held. O'Connell knew that without the beam gaps, the tanks would have punched through. He inspected each surviving gap after the fight. He checked load points with gentle pressure. He marked safe beams with chalk. He marked unsafe ones with a cross. His platoon used these marks to adjust their positions. Hours later, senior officers visited the site. They studied the angles used by O'Connell's teams. They documented distances and line of sight. They asked for a summary of the method. O'Connell explained the logic once more. He described how collapsed structures created natural shot lines. He highlighted how structural grain controlled stability. He emphasized the importance of low visibility and minimal exposure. The officers acknowledged the effectiveness of the tactic. They requested a written description that could be sent to higher command. O'Connell agreed. He sat on a piece of broken stone and wrote a clear explanation. He included details about angle selection, grain strength, and weight distribution. He knew his explanation might not reach formal doctrine, but he hoped it would help other units survive similar battles. O'Connell's written explanation reached brigade command 2 days later. Officers compared his account with multiple reports from the front. They concluded that the firing gap technique increased survivability and improved anti-armor effectiveness in dense urban terrain. They forwarded the summary to divisional staff. Higher command classified the method as an emerging field adaptation. It did not enter official doctrine, but field officers quietly encouraged its use. Engineers continued refining the technique. They built experimental models using scrap wood and rubble. They calculated how recoil transferred into different beam sizes. They found that thicker beams dispersed force better. They confirmed that angled reinforcement reduced collapse risk. They noted that grain direction controlled long-term stability. They used these insights to update their guides. Soldiers across the district received improved instructions. O'Connell continued training riflemen. He taught them how to carve narrow gaps without weakening beams. He showed them how to brace wood with scavenged nails. He demonstrated how to check for hidden fractures. His lessons were simple. Find stability. Find concealment. Find an angle the enemy does not expect. Soldiers applied these lessons in every fight. The tactic became second nature. They found beam gaps instinctively. They set up positions without hesitation. The battle for Caen pushed into its final stages. German forces weakened. Their armor shortages grew severe. They replaced lost tanks with whatever machines remained operational. These vehicles entered the battlefield with nervous crews. They advanced through narrow streets with caution. They stopped frequently to scan for threats. Their uncertainty showed how deeply O'Connell's tactic affected them. During one of the final engagements, a lone German tank attempted to break through an alley. It advanced slowly, firing sporadic rounds at suspected positions. The crew moved in constant fear of unseen shooters. O'Connell watched from a stable firing gap. He remained quiet. He studied the tank's movement. He timed its pace. When the hull dipped over uneven debris, he fired. The round hit the lower side plate. The tank halted. Smoke rose. The crew abandoned the vehicle and fled. Allied infantry captured them moments later. After the battle, O'Connell stood beside the tank and examined the impact point. His shot hit exactly where he aimed. The angle of the beam gap controlled the trajectory. The stability of the structure transferred recoil safely. His pre-war carpentry skill, applied in the harshest environment, stopped another armored threat. The district stabilized. Allied units pushed deeper into the city. O'Connell's platoon received new assignments. They moved to fresh sectors with different structural patterns. The men asked him how to adapt the tactic to new terrain. He walked through the new streets and mapped the available beams. He marked reinforced points. He warned them about unstable structures. They followed his guidance and set up new gaps. The method continued to save lives. German resistance collapsed over the following weeks. The city fell under Allied control. The firing gaps played a quiet but significant role. They prevented armored breakthroughs. They reduced casualties. They allowed infantry to hold ground that doctrine declared indefensible. The tactic became one of many small innovations that shaped success in urban combat. When the campaign ended, O'Connell received no formal commendation for his work. His name appeared only in marginal notes on field reports. Officers referenced his tactic without connecting it to him personally. This was common. Many life-saving innovations emerged quietly from soldiers with unique skills. Engineers, carpenters, miners, and machinists shaped battlefield adaptation. Their contributions rarely reached official recognition. O'Connell accepted this reality. He returned to his duties without complaint. He continued reinforcing beams, carving gaps, and training men. His focus stayed on practical needs. He saved lives because he understood structures, not because he sought praise. His platoon remembered him as the man who turned shattered timber into a weapon. Months later, when the unit rotated to a rear area, new recruits studied diagrams of reinforced firing gaps. They believed the method came from higher command. Few knew it began with a carpenter who refused to rely on predictable doctrine. Few knew his superiors banned the idea before it proved itself. Few understood how many lives it saved. Years after the war, veterans gathered and shared stories. Some remembered improvised firing gaps. Some recalled the first time they used one. A few mentioned a quiet sergeant who walked through the ruins and found angles no one else saw. They understood that innovation often came from necessity. They respected how one soldier's skill changed the fate of multiple engagements. O'Connell returned to carpentry after the war. He rebuilt homes in his old neighborhood. He restored damaged beams and repaired porches with a familiar sense of precision. Neighbors saw a craftsman. They never knew how those same hands shaped a tactic that crippled German armor. He carried the memories quietly. He remembered the lives saved. He remembered the soldiers who learned his method. He remembered the moment his gap dropped the Panzer crew that changed everything. He never sought recognition. He valued stability. He valued the chance to build again instead of tear apart. His wartime innovation never reached textbooks. It existed only in scattered reports and fading memories. But the soldiers who survived because of it never forgot. They knew that a carpenter's eye saved them when doctrine failed. The firing gap remained a minor but significant example of battlefield adaptation. It showed how civilian skills transformed into tactical advantage. It revealed how rigid doctrine could fall to practical ingenuity. It demonstrated that in urban combat, small innovations mattered as much as major strategies. The tactic helped shape the outcome of multiple engagements. It proved that sound judgment and resourcefulness could overcome armored power. O'Connell lived a quiet life after the war. He worked in construction. He raised a family. He taught apprentices how to identify stable beams and safe load points. He never mentioned the war unless someone asked. When they did, he spoke briefly. He described the ruined streets. He described the sound of tanks. He described the lives lost. He rarely mentioned his own role. Only those who served with him understood the full story. They knew how his firing gaps turned the tide during crucial moments. They knew how many tanks failed to advance because of a hidden angle carved into old timber. They remembered the days when German armor feared narrow lanes. They remembered how one man's skill changed the rhythm of battle. His innovation faded from public memory. But among the men whose lives depended on it, the knowledge remained clear. They survived because a carpenter saw the battlefield differently. They survived because he refused to follow predictable patterns. They survived because he trusted his craft more than the manual. His porch beam firing gap became a quiet symbol of resourcefulness under pressure. The story of Sergeant Thomas O'Connell remained tucked between forgotten reports and fading recollections. But the impact of his work lived on in every soldier who held ground against armored force. His legacy proved that simple ideas could shape the outcome of complex battles. His quiet ingenuity turned wreckage into defense. His firing gap dropped a Panzer crew and forced an entire sector to rethink how to fight.